Hello and welcome to Start Learning Complex Numbers, a video course where I introduce you to the field of complex numbers. So I want to show you how we can construct these numbers and how we can calculate with them. However, before we do that, I first want to thank all the nice people that support this channel on Steady or PayPal. Now the starting point for the complex numbers is the real number line R. There you should know we find all integers on the number line, all fractions, but also irrational numbers like the square root of 2. Moreover, we also know that we have two operations, the addition and the multiplication, and we know that they fulfill a lot of rules, such that we call R a field. Then we also have an ordering, so we can compare two numbers, and this ordering also satisfies some rules. Finally, the last property is the completeness, which tells us that there are no holes on this number line. Okay, then let's discuss what one can do with these real numbers here. For example, we can say that we are able to solve a lot of equations. Solving x plus 5 is equal to 1 is no problem at all. In the same way, we can also solve x times 5 is equal to 1. So here you can see we can use the property that we have a field. Then another equation we solved is x squared is equal to 2. This one leads to the square root of 2, which is in R by completeness. However, this does not mean that we are able to solve any quadratic equation. For example, the quadratic equation x squared is equal to minus 1 has no solutions. This is not hard to see because you can show that any square in the real numbers is greater or equal than 0. And we also need that minus 1 is less than 0. Here I can tell you, if you just work with the axioms of the real numbers, it's a good exercise to show both of these things. Then this implies that this simple equation does not have any solution. However, for us it makes sense that we extend our numbers such that this equation has solutions. The first thing you should note here is that x squared is nothing else than x times x. I say that because the same equation with the addition is solvable. So surprisingly, the addition and the multiplication act differently in R, which also has something to do with the ordering. Hence, our idea is to expand the number set such that we can solve such equations here, but we already know that we can't conserve all the properties in R. In order to see what we can do, let's look at the number line again. First, let's fill in the number 0, 2 and 4. Now you know we can go from 2 to 4 just by using multiplication. We simply multiply by 2. However, the interesting thing is now that we can split this big jump into small jumps. We just multiply by a number that is a little bit bigger than 1. You see, the smaller the one jump is, the more jumps we need. Okay, the splitting up does not work when we want to jump to minus 2. For this big jump, we have to multiply by minus 1. Also interesting here, if we multiply again by minus 1, we get back to 2. So here you see, multiplying with a negative number is different than multiplying with a positive number. Because in the first case, we immediately change the side of the number line. Now looking back to the splitting of the jump for positive numbers here, we can see the equation from above. Because doing two jumps with the number x means we have x squared is equal to 2. So exactly this equation where we know we have a solution. Now you might see the problem, how can we split up this jump into two parts? By looking at this picture, you might already see we could just add another direction for the numbers. Therefore, the idea is that we also include a y-axis now. Here, jumping from 1 to minus 1 is still given by multiplying with minus 1. However, now we are able to split it up into smaller parts. For example, into two parts where we multiply with the number x. And there you see, this is our equation from before. X squared is equal to minus 1. Hence you see, the number we search for is this point in the plane. So we need a new name for this number, we call it I. Now with our picture in mind, this I is now a special number because when we multiply I with itself, we get out the jump -1. Or to put it in other words, I squared is equal to -1. And this is now the important formula we should remember all the time. Okay, with all this, we have some idea what our goal is to expand the number set and how we can reach that goal. Extending the number line into a second direction is of course a completely new idea. Therefore, we really have to do this in a formal way, what we can do in the next video. In this way, I hope I see you there and have a nice day. Bye!